Welcome to math class. Today, we're going to be covering the topic solving quadratic and linear systems. Systems consisting of one linear equation and one quadratic equation may have two solutions, one solution or no solutions, or as I like to say, two, one, or none. We're going to graph both equations and locate the points of intersection to solve a linear quadratic system of equations. This is what a graph would look like if it has two solutions. It might look like this. You might have a negative linear function. You might have a parabola that opens down or up in this case. This is what a graph, a linear quadratic system with one solution would possibly look like. And this is what a graph with no solution would look like. They would not intersect each other. Okay, so for example one, what is the solution to the system y equals x squared plus x minus 6 and y equals negative 2x minus 2? So in this problem here, the very first one is our quadratic, and the second one is the linear. So this tells me we have a linear quadratic system. So there are a couple ways that we could do this. We could just start out by solving this by hand, and that's actually what I'm going to do here. So I'm going to take x squared plus x minus 6 and set it equal to negative 2x minus 2. Okay, now what I'm going to do is combine, so that way I get equals 0 on one side. So the 2x is going to come over. We're going to get x squared plus 3x. Add the 2 over, we get minus 4. So through factoring, I would be able to get to x plus 4 times x minus 1 equals 0. And that's going to give me the two solutions for the x to be at 1 and negative 4. Once I have the two x solutions that I'm going to need, I'm going to pick one of the two original equations and plug it in. Okay, so I'm going to choose the linear one here just to show you what it looks like. We're going to say negative 2 times 1 minus 2. Well, that's just negative 2 minus 2, which is negative 4. So one of the solutions is going to be at positive 1, negative 4. Okay, so I'm over here, positive 1, negative 4. I would expect one of the solutions to go through that area. Okay, then I'm going to take the other one. I'm going to say negative 2 times negative 4 minus 2. Well, that is just 8 minus 2, which is just 6. So the other solution is going to be at negative 4, 6. So go to my graph, go to negative 4, go up to 6. 1, 2, 3, 4, 5, 6. Okay. Now I can use Desmos to confirm this. I'm going to expect to see 2 points at 1, negative 4, and 4, or negative 4, positive 6. So let's take two Desmos here and graph this out. So we're going to have x squared plus x minus 6. Then I'm going to take on the second line, y is equal to negative 2x minus 2. And when we click on the points, where they intersect, we see that they're at negative 4, 6, and 1, negative 4. So this confirms what we were expecting. So I'm going to graph the quadratic function. I'm going to have an intersection at negative 3, or x-intercepts at negative 3 and positive 2, and a y-intercept at 0, negative 6. And it looks like negative 1/2 and negative 6 1/4. So going back to my other one here, let's finish drawing this out. So I'm going to have, like I said, at negative 3, 0. I'm going to go with a different color here. Let's go black. So negative 3, 0. I'm going to have one at 2, 0, and a point also. 1, 2, 3, 4, 5. Oops. One. Let's go one more down. And then there's going to be a vertex right about there. Okay, so then when I draw this out, it's going to go down. It's going to go through all these points. Okay, and then the linear function is going to intersect at the red points here. So our two solutions are negative 4, 6, and 1, negative 4. Now in example 2, we have x minus y equals negative 5 and x squared plus 2y equals 18. First thing we want to do is fix the equations so that they are y equals. I'll just move that up here just a little bit more. Okay, so this first one, we're going to take x minus y equals negative 5. We're going to rewrite it as y equals negative x plus 5, or be x plus 5 actually. Okay, so that'll be the first one. We're just rewriting it is all we're doing. There's our first step. Second step, we're going to take x squared plus 2y equals 18. We're going to rewrite this. First is going to be 2y equals negative x squared plus 18, and then we're going to divide it by 2 so that y is equal to negative 1/2 x squared plus 9. So there's our quadratic function, and we have our linear function. So we're going to graph these in Desmos. Okay, so let me take this one out. We have y equals x plus 5, and then we have y equals negative 1/2 x, gotta move to the right there, x squared plus 9. And we move this down just a little bit so we can see. Okay, so my green line is going to be the representing the linear function here. We're going to have a point at negative 5, 0, and 5, 0. So I'm going to go ahead and put some points there. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Okay, and then we'll connect those. So there's my 2 dots there. Sorry, thought I had it on there. Okay, and then let me get that kind of extended out. So there's your linear function. And then our quadratic function, let's see where it's going to intersect. It's going to intersect at negative 4, 1, and 2, 7. So let's draw some red points on here. Go back and show you that real quick. There you go, at negative 4, 1, and 2, 7. Okay, so we're going to have a point at 2, 7. So there's a point right here. This is my intersection. And we also had negative 4, 1. Okay, and then the vertex is going to be at, looks like 9, 0, if I'm seeing this right. Or 0, 9, I mean. There we go. So I'm just going to plot the vertex on this one. So let's go with purple. 5, 6, 7, 8, 9. Right there. Okay, and then we're going to go ahead and connect those dots as well. So the other points, it's not going to be perfect, but getting the idea. So the two solutions that we are looking for are going to be at negative 4, 1 and 2, 7. Okay, another method that we could use to solve a linear quadratic system is through substitution, and these are the steps that are involved. Step 1, we're going to solve the linear equation for the variable. Step 2, we're going to substitute the linear equation into the quadratic equation. Step 3, we're going to simplify and solve for a variable. So keep in mind, quadratic equations may yield 2 solutions. And then step 4, substitute the values found in step 3 into either of the original equations to finish finding the solutions. Okay, so example 3 says solve the system of equations. This is question A for example 3. We have y equals x squared minus 8x plus 14. So that's already solved for y. The second one, we have 2x minus y equals 7. So my goal is to substitute for y is what I really want to do. Okay, so I want to rewrite the second equation so it's y equals. And in order to do that, that tells me that I'm going to have negative y equals negative 2x plus 7. Then taking care of the negative, we're going to have y is equal to 2x minus 7. Okay, so we're going to take this and substitute it in place of y into the first equation. So it becomes 2x, let's go with the x squared first. So x squared minus 8x plus 14 equals 2x minus 7. Okay, so now solving, this is kind of like what I did for example 1 of solving by graphing. So I'm going to subtract 2x, so I'm going to get x squared minus 10x. I'm going to add 7, so it'll be plus 21 equals 0. And then you use any method of your choice. Well, for this one, these look like numbers that I could probably factor, which I can. 2 factors of 21, that are going to give me 10, is 7 and 3. So we're going to have 2 factors of x minus 7 times x minus 3, set it equal to 0. So from there, we can see that we're going to get x is going to have 2 values. It's either going to be at positive 3 or positive 7. Now what I'm going to do is I'm going to take those x values and plug them into either one of the 2 equations. For the purpose of this video, I'm going to show both of them to show you that it doesn't matter which one you use. So let's take the first one, the easy one. Let's plug in the x value into the linear function. I'm going to use the one where I solved for y already. So just testing it into the linear function, we're going to get um, y is equal to 2 times 3 minus 7. So that means we're going to get 6 minus 7, which is negative 1. Okay, so there's the first y. So whenever you get, there's one of our solutions. It's going to be at 3, negative 1. The second solution is going to come out from multiplying 2 times 7 minus 7, which is 14 minus 7, which is equal to 7. So the second solution says it's going to be at 7, 7. Okay, so that's using the linear side. Now, what if I had chosen the quadratic side? We should still get to the same solutions. Okay, so we're going to have y equals x squared, so 3 squared, minus 8 times 3 plus 14. Okay, well, that's 9. I'm going to go a different color here. So that's 9. That is minus 24. We're going to add 14. Okay, so we're going to go 9 minus 24 plus 14. We're going to get negative 1. So this says that one of the solutions is going to be at 3, negative 1. Okay, if I plug it into the other one, y equals, the other one is going to be 7. So 7 squared minus 8 times 7 plus 14. Go down just a little bit further here. We're going to have, let's say 49 minus 56, add 14. So 49 add 50, or subtract 56, add 14, we get 7 also. So that does confirm. It doesn't matter which function you plug it into. You just pick one and plug it in. So our two solutions are just simply 3, negative 1, and 7, 7. Okay, in this next one, we have y equals negative 5x squared plus 20 and y equals 10x plus 50. So we have the quadratic, we have the linear. So what we can do is set them up to equal each other. So we're going to have negative 5x squared plus 20 equals 10x plus 50. Okay, now if I want to get the constants on one side, I'm going to go ahead and move the 10x to the left, the 20 to the right. So this is going to give me negative 5x squared minus 10x. Get some space equals 30. Okay, and the reason I'm doing that is because I'm going to solve this one by by completing the square. So I'm going to take out a negative 5 first. That's what I'm going to do. So let's pull out the negative 5. So it goes negative 5, and then you get x squared plus 2x equals negative 6. And then we're going to add negative b over 2. So this is going to be negative 1 squared. Okay, so that's going to give me, let's see, on the right, we're going to get negative 5. On the left, we're going to get, um, because of my constant here, we're going to have x plus 1 squared. And so I'm going to use the inside part of the brackets in order to find the rest of the solution. So it's a little bit easier than multiplying through and then have to undo. So we're going to take x plus 1 squared, set it equal to negative 5. We're going to take the square root of both sides. So x plus 1 is equal to the square root, or plus or minus the square root of negative 5. Okay, I have a negative radicand, so that means I have an imaginary solution. So this is going to be x plus 1 is equal to plus or minus I times the square root of 5. And then we're going to subtract 1. So we're going to get negative 1 plus or minus I square root 5. And so when you get that, what this is telling you is that the intersections does not exist between the line and the quadratic, the linear and the quadratic. Okay, so let me pull this over into Desmos so you can see what that would actually look like. Okay, so we're going to take the function y equals negative 5x squared plus 20. Okay, there's your function. And then I have y equals 10x plus 50. Okay, so I'm going to have to move around. You can see for one, it's almost like it's running at the same slope as well as that. But these two functions are never going to cross each other. They're never going to cross paths. So it's an imaginary solution. So therefore, we cannot find the y value by plugging something in. So we have to settle for this being the answer. Okay, so that would be our final answer is that. There are two imaginary solutions. All right, so example 4, we have a commercial aircraft left a contrail, that is the condensation trail that you see airplanes leaving in the atmosphere, in a linear path starting at 5 miles directly overhead and continuing horizontally for 30 miles. So this is my commercial airline. It's flying along this blue path. It's a linear path. Okay. It reached a height of 6.5 miles above the ground after 30 miles horizontally. A pilot training in a fighter jet, so here's my fighter jet, it's left a contrail in a parabolic path reaching 5 miles high at a horizontal distance of 10 miles, 6 miles high at a horizontal distance of 20 miles, and 5 miles high at a horizontal distance of 30 miles. Where do the two aircraft's contrails intersect? Okay, so we're going to take a look at the data that we were given from the situation. The commercial airlines table would look something like this. We have at zero at the starting point, was at a 5 mile height. After 30 miles horizontally, it reaches 6.5 miles high. Okay, and then our fighter pilot has a horizontal distance of 10 and a vertical distance of 5, horizontal distance of 20, vertical distance of 6, horizontal of 30, vertical 5. Okay, so we're going to take these tables and plug them into Desmos. So first thing I'm going to do is I'm going to set the table here, X1, Y1. This is going to be my commercial airline here. So 0, 5, and 36.5. Okay, and then I'm going to use the regression function here. So we're going to add a linear regression of 0.05x plus 5. So the function that represents the commercial airline is y equals 0.05x plus 5. So we'll go ahead and draw a box around that. And then we're going to get the commercial, or we're going to get the fighter pilot. But before we do that, let's copy that function into Desmos here. So then we're going to add another table. And this table is going to have 10 and 5, 26, and 35. Okay, we're going to add a quadratic regression. So click the regression button, go to quadratic regression, and then we have our function of y equals negative 0.01 x squared plus 4x plus 2. Okay, and we'll draw that box around it. So these are the two functions we're going to use. I'm going to copy that over into Desmos as well. And I'm going to get rid of my table. Okay, so the next part is we're going to find the intersections of those two functions. Okay, so let's find the intersection. Let's set these functions equal to each other. So negative 0.01 x squared plus 4x plus 2, set it equal to the commercial airline, so 0.05 x plus 5. Okay, and what I'm going to do is I'm going to subtract 0.05 from this guy here. So it's minus 0.05 x, and we're going to subtract 5 from the 2. So we're not touching the negative 0.01 x squared. So that's going to manipulate this equation. It's going to change it to be negative 0.01 x squared plus 0.35x minus 3 equals 0. Okay, so here's my a. What I'm going to do is I'm going to use the quadratic formula this time. So there's your a, there's your b, and here's your c. Okay, so we're going to take this into the quadratic function. So x equals, or quadratic formula, b, so 0.35 plus or minus, and then we're going to 0.35 squared minus 4 times negative 0.01 times negative 3. That'll be underneath the radical. Okay, and then we'll divide it by 2 times negative 0.01. Okay, this is going to give us 0.35 plus or minus. Let's take the square root of this. As you can see, we have a negative times a negative times a negative. We do want to make sure that we're going to get solutions, so let's check the discriminant. So that'll be the highlighted part here. So I'm going to highlight that. Okay, that's going to be our discriminant. We want to make sure we're going to actually get solutions for this. Okay, so let's type that in. We're going to get 0.35 squared minus 4 times negative 0.01 times negative 3. And we are going to get a number, a positive number, so we are going to have some solutions. So 0.0025, and we're going to be dividing that by negative 0.02. Okay, so now that we have our two possible solutions, let's take this whole thing, let's type these in, and let's just get some solutions here. So, oh, and I totally forgot. This, of course, is just me kind of getting too fast for you. So there should be a negative right in front of the b. Don't forget that it's supposed to be negative b plus or minus. So now if I go back into Desmos, okay, we're going to set this this is my discriminant. So D equals, that's what we're going to do. So that way all I have to do is go into here. We're going to go fraction negative 0.35 plus square root of D divided by negative 0.02. Okay, one of the solutions is going to be at x equals 15. Okay, there's your one. So 15 miles horizontally. Okay, and then so that's a horizontal distance. And then we'll get the other one. So minus the other one's going to be at 20 miles horizontally. Okay, and now what we're going to do is we're going to take those values, 15 and 20. We're going to use one of these functions that was here originally. We're going to just change it to be function notation. So we're going to call f of x, and we'll call the other one g of x. See, this is the fighter pilot, so this should be f of x, and we'll call the other one c of x, since that's a commercial. Okay, now let's call these functions here. We don't need these two now. We're going to pass in to c. We're going to pass in a horizontal distance of 15. And also let's pass in a horizontal distance of 15 to the fighter jet as well. And you see how you get to the same result. So it should be 5.75. So at 15, we're going to have an intersection. So 15 miles horizontally, we're going to intersect at 5.75 miles in the air. So there's one solution. Okay, now the other solution, we're going to pass in 20. And you can see at 20 miles, well, the aircraft is going to be at 6 miles in the air, or the trails are going to be at 6 miles in the air. So we're going to be at 20 and 6. All right. That covers it. This whole video is just on how do we take a linear and quadratic system and figure out where they intersect. Okay, so thank you for watching, and I'll see you next time.